Okay, I want you to try a little visualization experiment with me.
Yeah.
Imagine you wake up tomorrow morning. You walk into your kitchen to make coffee. Something just feels off.
Uh-huh.
You reach for a mug, but the handle is on the wrong side. You try to open the fridge, the hinge is reversed. You pick up a pair of scissors, and they won't cut because the blades are crossed the wrong way.
That sounds incredibly frustrating.
It would be, right. It would feel like the world had been flipped, like you were trapped in a mirror.
Right.
But here's the thing. In a way, we are already trapped. One of the biggest, most headache-inducing mysteries in cosmology is that our universe seems to have a preference, a handedness.
And not just for scissors?
Not just for scissors, but for the fundamental stuff we're made of.
You're touching on what we call the Barryan asymmetry problem, but
Yeah,
it goes even deeper than that.
exactly. Standard physics tells us that when the Big Bang happened, it should have been a perfect 50-50 split.
Matter and antimatter.
Two sides of the same coin. But look around. I am made of matter. You're made of matter. This microphone. It's all matter.
So the question that keeps physicists up at night is, where did all the antimatter go?
It's the ultimate vanishing act. And usually the answers involve some very complex, very subtle symmetry breaking in the early universe. But today, we're looking at a source that proposes something else.
Something completely different. A framework called
Celominisignum.
Celominisignum.
What? Is that Latin, or did someone just fall asleep on their keyboard?
It does sound a bit like a spell from Harry Potter, doesn't it?
A little bit, yeah.
But Celominisignum is the name of the framework we're unpacking today. The source document, it's titled ChatGPT Chirality Antimatter Correlation 012126, which is a mouthful.
Okay.
But the ideas inside are even bigger. It argues for what it calls a unifying explanatory advantage.
Which is just fancy talk for this one idea explains a whole bunch of weird stuff at once.
Precisely. It connects the missing antimatter to black holes and even to the specific way your DNA spirals. But the core proposition is the real mind-bender. It suggests we shouldn't view the universe as being made of stuff. Particles, atoms, rocks.
But as being made of information.
Information.
And that is our mission for this deep dive. We're going to unpack how this theory reframes reality, and the best part, how we can actually test it. Because this one says, don't take my word for it, go to the lab.
And that's so crucial, because while this might feel like science fiction, the source material really tries hard to keep it grounded. It's not trying to break the laws of physics.
It's trying to reinterpret what those laws are actually telling us.
Exactly.
Okay, let's get into the nuts and bolts. To understand this, we first have to deal with what you called the mirror problem.
Right.
We mentioned antimatter. Most people know it from, starships or that movie Angels and Demons. But what is it really?
So in standard physics, it's not just matter with an opposite electrical charge. It's a mirror image in a very specific way. We talk about CPT symmetry.
CPT. Okay, acronym time. Break it down.
C is charge, so positive becomes negative. Got it.
P is parity, which is basically left becoming right, a spatial reflection.
A mirror image.
And T is time.
Whoa, hold on. Time. We have to reverse time to get antimatter.
Mathematically, yes. If you take an electron, you flip its charge, you reflect it in a mirror, and you run the film of its life backward. It behaves exactly like a positron.
An antimatter electron.
Right. The laws of physics are supposed to respect this symmetry.
Okay, so it's a perfect mirror universe. But this deep dive focuses heavily on that middle one parity, or as the source calls it, chirality, which is just Greek for handedness.
Correct. Your hands are chiral. They're non-superimposable mirror images. And no matter how you turn your left hand, it will never look exactly like your right hand.
Unless you use a mirror.
Exactly. And you might think, okay, that's just geometry. But nature is absolutely obsessed with this.
I was looking at the examples in the source, and it's actually kind of spooky.
It is. Take amino acids, the building blocks of life. Chemically, you can make them left-handed or right-handed in a lab, and you get a 50-50 mix.
But in your body, in every living thing on Earth, they are almost exclusively left-handed.
And sugars are right-handed. It's like life picked a team and just stuck with it.
Exactly. And this isn't just biology. In physics, the weak nuclear force, the one responsible for radioactive decay,
it violates parity.
It violates parity. It has a preference. It's a deep, fundamental asymmetry. And the source argues this link between antimatter and chirality isn't a coincidence. They're expressions of the same underlying thing.
Okay, and this is where we get to the red pill moment of the theory. The framework flips the script. It says, Matter is not fundamental. Information is.
This is the pivotal shift. If you start thinking of the universe as an information processing system, your definitions have to change. The framework proposes that what we call matter
Is stuff we see and touch.
is actually kinetic information.
Kinetic,
Yeah.
like moving, active.
Active, expressed processing. It's the program that's currently running.
And so antimatter is.
Potential information. Stored. Unexpressed. The code that isn't running right now.
Okay, I need an analogy here because my brain is starting to cramp a little.
Okay.
Usually we think of matter and antimatter annihilating. Boom, huge explosion, energy everywhere. If we use this information definition, what is that explosion?
Well, think about a battery and a fan. The energy in the battery is potential.
Right.
The spinning fan is kinetic. Now, what happens if you try to force the fan to run backward against the current? You get sparks, heat, a burnout.
The annihilation.
In this framework, yes. When matter, which is kinetic, meets antimatter, which is potential, it's not destruction, the source calls it informational symmetry resolution.
They neutralize each other.
They neutralize. And the energy release we see is just a byproduct of the information collapsing from kinetic back to a neutral zero state.
That is a completely different way to look at an explosion. It's not violence, it's data resolution.
It's the equation balancing itself.
But this raises a huge existential question for me. If the universe is full of this kinetic information matter, and there's supposedly all this potential information antimatter out there, why don't we just poof out of existence?
Right. Why doesn't everything just neutralize right now?
Yeah.
That is where the theory introduces the safety lock. This is the part I found really elegant. It asks, why does chirality exist?
Why do we have this specific handedness?
The source argues that chirality acts as an informational phase lock.
A phase lock, like a safety on a gun.
Or a password on a file. The idea is if two objects have opposite informational chirality and they're both kinetic, they would neutralize, they annihilate. So to exist stably, systems enforce same-handedness.
So let me get this straight. The reason I'm made of left-handed amino acids,
Yeah.
it isn't just because evolution flipped a coin a billion years ago and it came up tails.
The source argues it's a requirement for existence. Life acquires that homochirality to remain stable. If you mixed left and right indiscriminately at that fundamental level, you might risk what it calls destructive symmetry collapse.
So you need that asymmetry, that bias, to keep the information from just canceling itself out.
Exactly.
That is actually terrifying. It's like saying my DNA spirals left, because if it spiraled right in this universe, I'd just unravel.
Not just unravel, but resolve. It's like a key in a lock, but the lock is designed to keep the wrong key out so the door stays shut and the room doesn't vanish.
Okay, so chirality keeps us safe. It keeps the kinetic separate from the potential, but we still have the original problem. If matter is the kinetic stuff and antimatter is the potential stuff, where is the potential stuff hiding? Because we don't see it.
The source has a specific answer for this, but I have to warn you, it's going to sound a bit convenient at first.
Let me guess. Black holes.
Black holes.
Of course. It's always black holes. Isn't that a bit of a cop-out? Hey, where's the missing half of the universe? Oh, it's in the invisible pit where we can never, ever check.
I completely understand that reaction. It does sound like a God of the gaps argument. But hear me out, because the source ties this to a very real concept in modern physics called the holographic principle.
Okay, remind us what that is.
The holographic principle suggests that all the information inside a volume of space, like a black hole, can be described by the information on its boundary, its surface.
So, like the label on a soup can.
That's a great analogy. The contents are 3D, but the 2D label tells you everything about what's inside. The holographic principle says black holes are like that label. They store information.
So in this Celominisignum framework, black holes aren't just gravity monsters, they are storage devices.
Exactly. Informational reservoirs. The theory proposes that black holes store the potential information, the antimatter complement, without it needing to physically manifest in our space.
So they're like cosmic hard drives backing up the data that isn't currently running on the screen.
That's the idea. And this solves the scarcity issue. We don't see antimatter floating around because it's not kinetic. It's locked away in a potential state inside these gravitational sinks.
So the universal balance is still there, it's just hidden. Locally, we only see the kinetic side.
And that's why the universe appears matter-dominated without violating the fundamental need for balance.
All right, I'll admit, the cosmic hard drive idea is compelling. But you know me, I love a good story, but I love proof more. If you can't prove it, it's just philosophy.
And that is exactly what the source emphasizes. It explicitly states, This is useless if it can't be tested.
I respect that. Put up or shut up. It outlines what it calls pre-registration style experiments. Before we get into them, why is that term pre-registration important?
It's vital for scientific integrity. It means you state your prediction before you run the experiment. You say, if I do X, Y will happen. If Y happens, great. If not, you're wrong. No moving the goalpost after the fact.
Got it. So let's look at test number 1, the glove test.
All right, this is a particle physics experiment. The setup is you shoot low-energy positrons, antimatter electrons, at what are called enantiopure targets.
Which just means pure-handedness, right? Like a film made of all left-handed molecules versus one made of all right-handed molecules.
Correct. Now, here are the stakes. Standard physics says that, except for some tiny, tiny weak force effects, an antiparticle shouldn't care if the target is left or right-handed. The annihilation rate should be virtually identical.
But Celominisignum says chirality is an informational lock.
Exactly. So the prediction is that if you shoot these positrons at the left target versus the right target, you will see a measurable difference.
A difference in how they annihilate.
Yes, or in how they form something called positronium. There will be a statistical bias.
I love the 6th grader analogy the source uses here. It asks, do tiny antiparticles care if a glove is left or right-handed?
If the answer is yes, if there's a real difference, then standard physics has a lot of explaining to do. It would mean antimatter recognizes the informational state of matter. That would be massive. Nobel Prize territory. Okay, experiment 2, chemistry and biology, the mirror life test.
This one appeals to our intuition about stability. The proposal is to build 2 systems. One is the normal system, standard left-handed enzymes, natural substrates.
The stuff life is made of.
The other is a mirror system, right-handed enzymes with mirror substrates.
So chemically they are identical, just flipped.
Standard chemistry says they should behave identically. If you heat them up, they should break down at the same rate.
But the theory predicts...
What?
It predicts the mirror system might be less stable, more prone to errors, or it might break down faster under stress.
But why? If the chemistry is identical, why would it be weaker?
Because if chirality is a stability lock designed for our specific universe's kinetic state, the mirror version might not be locked as securely against the background of potential information.
The analogy here is great. If we build 2 identical towers, one normal and one mirrored, does the mirror one fall down faster in an earthquake?
Exactly. If the mirror tower collapses first, it suggests handedness isn't just geometry. It's a fundamental structural requirement for existing in this reality.
That is so wild. It implies there's a preferred direction for reality itself, like the universe has a grain, and if you go against the grain, you splinter.
Which brings us to the 3rd experiment, dealing with black holes. Obviously, we can't go to a black hole and poke it.
Not yet, anyway.
So we build analog black holes in the lab. You can use sound waves in fluids or optical systems to create horizons points of no return.
The sonic drain.
Right. The experiment is to set up these analog black holes and measure the radiation they emit, the analog of Hawking radiation. The prediction is that the radiation should show a handedness bias.
It should prefer left or right.
Based on how the information was fed into the system, yes. Standard physics would say the radiation should be random, or at least symmetrical. But if the drain remembers which way the water swirled,
then the radiation will show that bias. Does the drain remember which way the water swirled? That is such a simple question, but the implications are huge.
If any of these experiments showed a positive result, we would have to rewrite the textbooks. We'd move from a universe of particles and forces to one of information and processing.
So let's wrap this up. What does this all mean for someone listening to this? Why should they care about chiral locks and potential information?
I think it connects to a concept that the physicist John Archibald Wheeler proposed decades ago. It from bit.
It from bit.
The idea that every particle, every field derives its very existence from bit, from binary yes or no choices, from information.
So the universe, at its absolute bottom layer, isn't solid, it's data.
It's answers to questions. We're living in a data stream. And this Celominisignum framework, it provides a potential mechanism for that. It doesn't contradict the equations we have, it reinterprets them.
It tells us the reason we're here, the reason we're solid matter, is because information has been kineticized.
It's been expressed.
That concept of kineticization is stuck in my head. It makes me feel, I don't know, temporary.
It is the final provocative thought the source leaves us with.
Yeah.
If matter is just information that is snapped into a kinetic state, what triggers that transition? And it asks, Are we just the expressed side of a universe that is half potential?
It's a haunting thought. I'm going to be staring at my hands all afternoon, wondering if I'm just a kinetic glitch in a potential universe.
Or maybe not a glitch, but a feature.
Ah.
The kinetic side is where the story happens.
The potential side is just the ink waiting in the pen.
That's a good way to put it.
That is a slightly more comforting way to look at it. We are the story.
We are.
Well, on that note, thank you for joining us on this mind-bending journey into the architecture of reality. Keep asking questions, keep looking at the mirrors, and maybe check if your scissors are working correctly. We'll see you on the next deep dive.